All right, while you guys are getting settled, I will say hello and introduce myself. My name is Cornelia Davis. I am a platform engineer on the Cloud Foundry team at Pivotal. I normally work out of the San Francisco office, and I'm just here on the East Coast visiting customers and doing meetups. So thank you very much for coming today. So you might be wondering what the heck a platform engineer is. So what we do in platform engineering is we're really all about kind of pushing that envelope of the product. So Cloud Foundry is used a particular way, and there's very well understood ways to apply it and extend it and all of those things. But as we're out there working with the customers and working with partners, people are always wanting to push that envelope. They want to do more. And so we're an engineering team. We work out of the core Cloud Foundry engineering team. We're an engineering team that's really focused on pushing that envelope, working with customers and partners to go beyond what we've done so far with Cloud Foundry. So I spent a lot of time out in the field. I came to Pivotal from EMC. I'll tell you a little bit more about that. I worked in the EMC CTO office for a number of years, I come from the app dev side, and I'll sprinkle in a little bit more about that as well. So what this meetup is about it's about taking a multi-tier application, something that we're all very familiar with, that we've been doing for a couple of decades already, and how do I deploy that onto Cloud Foundry? So before I dive into the material, I want to understand a little bit about my audience here. So how many people in the room are brand new to Cloud Foundry? Okay, all right. It's about what I expected. I did this meetup last night in New York City, and it was about the same. It was about half the people. So I'm not going to dive into all the nitty-gritty details. We will spend about 15 or 20 minutes kind of doing an overview of Cloud Foundry. I'll do a first demo, push an app, kind of give you what the essence of Cloud Foundry is before we start drilling into what it means to deploy things onto Cloud Foundry and why I had to make changes to an existing app that wasn't Cloud Foundry focused to start. And then the other thing is, how many people here are Pivotal Labs or Pivotal people? Oh, most of you. Okay, good. So then, thank you for hosting me here in your office. I'm so glad to be here. Okay, super. So let me then spend, like I said, a little bit of time. I'm going to sprinkle a lot of stories throughout the talk. Like I said, I spend a lot of time with enterprise customers, with partners and stuff, and I'll give you a little perspective of what we're doing out in the field. Okay, so before I jump into the slides then, let me go over here. So what we see here is the Cloud Foundry UI. Now, I'm doing this whole demo on our public offering, so on run.pivotal.io. So if you don't already have an account, you can go there and you can sign up and you can get 60 days for free. And the reason I want to start here is I want to show you what the main abstractions are in Cloud Foundry. But before I even drill into that, let me tell you something that I learned over the course of the last couple of years. So I've been working with Cloud Foundry for about 2 years, almost 2 years. I was doing so in the EMC CTO office because I kind of did emerging tech when I was in the CTO office. And one of the emerging tech things that we were working on was understanding platform as a service and understanding Cloud Foundry. And so I come from the app dev side. I do not come from the IT operations side. I'm an app developer by decades of career and training and so on. And so, but when I started learning Cloud Foundry, I got super charged up about it because I thought it was all for the developer. I thought it was all about me. I thought it was for me. And if you read what's written out there about platform as a service, it's easy to think that. It's easy to think, oh, it's all for the developer, because you go to places like InfoWeek or ZDNet or any of those rags out there, and they all talk about PaaS is for the developer. It's all about making the developers' lives easier. And like I said, I've been a developer for decades, and I've never really found anybody who was really all that invested in spending a lot of money on making my life easier. That wasn't what was motivating the people who had the budget. And so there was always that little thing in the back of my mind of, okay, this is really cool, I really like this, but these markets that people are projecting for platform as a service don't seem to be in line with making developers' lives easier. And over the course of these 2 years, relatively recently, I would say within the last 6 or 8 months, all of a sudden it dawned on me that this product is as much for the operator as it is the developer. So I'll show you some of those operator features as we go through this demo, and I'll emphasize that over and over. Okay, so let me put my developer hat back on. So now I'm going to be the developer and say, okay, I want to develop an application. I'm going to do some local development. That doesn't go away, obviously, because I have my IDE locally, and I'm going to be able to do my source level debugging and all of that. None of that is really going to change. But then when it comes time for me to actually test this thing in a real setting, I want to deploy it to an app server. I want to deploy my web tier. I want to deploy my services tier. I want to get all those things. That's where I'm going to come to Cloud Foundry, and I'm going to start to deploy things, and then I'm going to run tests against that. So what do I do as an app developer? Well, in the old world, old world, I needed to have my own server. And I have had many a server sitting under my desk where I stood everything up. I'm working in a particular area, so I configured that server so that I could have my own Documentum instance, believe it or not, under my desk. So if you don't know Documentum, it's this big old content management system. So I spent a couple of years in the Documentum CTO office as well. And I had a system that had Documentum on it, and I had to install it all myself. Then virtual machines started coming along, and I could start to stand up virtual machines. So I could either run VMware Workstation on my machine, or EMC started provisioning VMs for me, an IaaS-based solution. But then I still had to install a bunch of stuff. I still needed to install my OS and my app server and all of those things. What I do now in the Cloud Foundry world is I am not speaking that infrastructure dial tone anymore. I am not speaking virtual machines, networks, and storage. I am speaking different abstractions. The abstractions that I speak when I'm working with Cloud Foundry is I speak in terms of applications and services. That's it. Okay, I don't have to worry about machines anymore. And so what I want to show you is this is the user interface. We have a couple of organizational structures. We can break things down into different orgs, and then orgs contain spaces. Now then spaces in turn have team members, so you have roles in certain spaces, and they also contain the applications and the service instances. So here I am in my production space. You can see that only a limited number of people have access to the production space, and I've only got a limited set of applications and services deployed there. But if I go into my development space, you'll see that there's a great number of applications, lots and lots of apps, lots and lots of service instances, and a much broader set of team members that have access to that development space. And so this is what I'm interacting with. I'm going to go back over to my production environment, and I'm going to show you the deployment of an application. Now, I'm a propeller head, so I'm going to do that from the command line. This is a technical talk. So I'm going to come over here and show you, first of all, this is the application I'm going to push. So Cloud Foundry will run applications that are written in lots of different languages. Out of the box, we support Ruby, Node.js, Java, and Golang. Those are built in already. We just had a community meeting this morning where we voted and decided to move PHP and Python into the main branches of Cloud Foundry as well. So now we have PHP and Python support as well. So you can push applications written in all those languages into Cloud Foundry, and we'll take care of the rest for you. So here I have a Ruby application, super, super simple application, and I'm going to push this into Cloud Foundry. And so the first thing that I need to do is I need to identify which cloud I'm going to push this into. And the way that I do that is I want to push it into the same cloud that I'm logged in here, which is my run.pivotal.io. So from the command line, I'm going to say GCF, which is my command line client. If you download it, it'll just be CF. So ignore the G for a moment because I just have a couple of versions of the client, and this is the version that I want to run here. So I have an alias. Yes? You bet. That better?
Yeah.
Okay. So I'm going to do a GCF API, and basically what I'm doing is just connecting to the API endpoint for the cloud. Run.pivotal.io. This is okay, great. And then I'm going to log in. And I'm already logged in, but I'll show you what that looks like anyway. Very, very simple. My email address. And my password. And now I'm logged in. And it's going to ask me, again, what org and space do I want to go into? So I'm going to select the platform engineering organization, and I'm going to go into the production space. Okay? So now if I do a GCF apps, you'll see the same apps that I showed in the console. For GCF services, again, same apps that I have in the console. I mean, same service instances that you saw in the console. So now I'm going to deploy this new application, and I'm going to say GCF push. It's a very tiny application, so I'm going to allocate only a very small amount of memory to it. And then, meetup Toronto. It's a long name, but that's okay. I won't type it too many times. And I give it a name for the application. And that's it. And you'll see in a few moments that we'll have this application deployed. So I promised you that PaaS was not just for the application developer, it was also for the operator. Check this out. I'm deploying this into production. And one of the first operator features that I get is that I get a URL assigned. So I have my PaaS configured so that cfapps.io is a domain that I have available. And I can allocate things out of that domain. So by default, I take the name of the application and the default domain, and I allocate a URL from that. You'll see in a moment that once this is deployed, we automatically update the routers with that URL pointing to the application instance that's deployed. Okay, so that's another operator feature, is I don't have to go in and create DNS entries. We take care of all of that for you. That's a very, very concrete operational benefit. So that's the first thing that we've done is we've allocated a URL. Then the next thing that we did was we uploaded the application. So remember when I did the LS, there were those 6 files. Really only 4 of them mattered. I just uploaded all of them anyway. So what we did was we zipped up those 6 files, uploaded them, and you can see that it was 1.8K. Now it's a Ruby app, right? So it needs to run in a Ruby runtime. But I didn't have to bundle in that Ruby runtime. I didn't have to do any of that. The PaaS is going to do that for me. And that's what you see scrolling up here on the screen next. So you can see this is what we call the staging process. So it's taken those application bits, it's recognized that it was a Ruby app, and it did so by seeing that it had a gem file. If it had a web inf directory, for example, in a WAR file, it would assume that it was a Java file. So there's logic in there that it figures out what the application is. Once it's figured out that it's Ruby, it went and it laid down the runtime environment for me. So I didn't have to do any of that. So it took a look inside of the gem file. It first of all laid down Ruby. Then it laid down the dependencies that it found in the gem file. And then it laid down the application on it. And then it took that whole thing and it bundled it up in what we call a droplet. That's what you see here, where it says uploading droplet. So notice that the application that I uploaded was 1.8K, but once I prepared the runtime environment, I had 13 meg. Okay, so it actually increased in size because I laid a bunch of stuff around it. Then it took that droplet and it deployed it. Now, this isn't a Cloud Foundry architecture talk, it's more from the developer side, so I'm not going to spend the time going into the architecture, but I will tell you that when we run it, we do not spin up a brand new virtual machine. We have a pool of virtual machines that are called DEAs, Droplet Execution Actors. So the droplet execution actors are the VMs that are responsible for running the droplets. And the droplets are the prepared applications. So those VMs are already allocated. What we do is we carve out some of the resources using containering technology. If you're thinking Docker, you're along the right lines. Currently, it's not Docker. Currently, it's our own implementation. It's called Warden. Why did we do Warden? Well, we started building it 4 years ago before there was Docker. So we are moving in the direction of Docker, and there's a whole bunch of reasons for doing that. But all you need to know is what we're doing here is carving out, setting up a new lightweight Linux container, deploying the droplet into that, and starting it up. As soon as it starts up, we update the router with that URL and where that application is running. And now I can take that URL and I can run in the application. Well, the application's running. I can access the application. And this is the part of the presentation where you see that Pivotal is not paying me for my web development skills. I am the propeller head. You will see food bar somewhere on my slides. So I think that's a right that I have as a computer science person, is that I can use things like food. So here's my Hello World app. It does have one bit of information on here that I want you to take a close look at, and that's the port number. So notice that we're running at port 166, 61166. So remember that 166. And I can refresh it several times. Let me show you another one of those operational benefits. We have log aggregation built in. So as soon as you deploy something, we have a logging system that starts gathering the logs around that application. Remember I said that your units of currency with Cloud Foundry are apps and services? So you don't have to SSH into a box to look at logs. What you want is, I want the logs for my app. I don't want the logs on a machine. I want the logs for my app. So we have a command for that. It's cf logs, and I give it the name of the app, which is Hello Meetup Toronto. So now I'm connected and I'm tailing the logs. So let me come over here and generate a little bit of application traffic. So I refresh a couple of times, and I come over here, and you can see that I have log output coming out. So right here, app instance 0, that's the application log. There's not much going out in the logs for the simple application. And you'll notice also that there's more than just the application logs. You'll notice that there's an entry that's labeled with RTR. That's the router. So we aggregate logs from all these different components that are doing work on your behalf into one area. So you can now imagine that if I've got applications out there running, my application operator is responsible for keeping those things running. One of the things that they always look at is logs, right? They're looking at logs, they're looking at metrics that are coming out. So here, you can take this log output and you can stream it to something like Logstash or Splunk. And then you can use those tools to do your, Splunking through the log files, your searches and so on. Very much an operational benefit. Sure, the developer is going to look at the logs and see that things are working right, but the operator is the one who's really depending on those logs day in and day out to keep the application up and running. Now let me come over here and show you just one more feature on this before I jump into the regularly scheduled program. If I refresh this now, you'll see that that application instance is going to show up on my dashboard. Here it is, Hello Meetup Toronto. And I'm going to drill into that, and you can see some information about it. You can see that it used the Ruby build pack. Build packs is something that we use. Build pack is what encapsulates that runtime environment. You can see it's running on Ubuntu. You can see the route that was allocated for it. You can see that there's a single instance. Now I want to scale that up to 2 instances. But before I hit save, let me come over here and increase the font size again. I'm going to do a GCF apps, and here you can see, let me clear the screen, GCF apps. You can see that I have that instance of that application running. You can see that I have another application running here where I have 2 instances running. So what I want to do is I want to change that Hello Meetup one to having 2 instances. So let me save this. There we go. And come back over here and quickly do a GCF apps. I was fast enough. But let me hit GCF apps again. Okay, so notice that I did those 2 within a couple of seconds, a second or 2. So the first time I did it, the system knew that I wanted a second instance, but it hadn't started it yet. It was in the process of starting it. When I did it a second later, it knew that I wanted 2 instances, but it actually had the second instance up and running. So I was able to scale that out to 2 instances in a second. Now, if I had to spin up a whole new virtual machine, a whole new VMDK, a whole new AMI, and install middleware and install the bits, it would have taken me minutes and minutes and minutes. The reason I can do this is because of the architecture that we create this droplet. We now spin up a new Linux container, unzip the droplet, applet start up a process. We can do that all in a second. So that's how we can scale that quickly. So now if I come back over to the app and I do some refreshes on it, you can see I was at 166, and I do a refresh, and I hit 166 again, hit a refresh again, and now I'm at 853. So 166 and 853. If I come back over to the logs then, you can see that I now have stuff streaming out from application instance 0 as well as application instance 1. So from an operator perspective, this is freaking huge because I've got these two instances that are running on two totally different servers. And I don't have to go SSH into one box and SSH into the other. Something's going wrong with one of my apps and I have to scratch my head and go, well, which box is it running on? You don't need to answer that question. It doesn't matter which box it's running on. We're aggregating the logs for you. So that's pretty huge. So let me show you one more operational benefit here. Oh, there's so many. I get so excited. So there is, I did a talk. We had our CF Summit, which was our Cloud Foundry Summit, our conference a couple of weeks ago. I did a lightning talk on the 4 levels of HA. So I did it covered 4 levels of HA in our architecture in 5 minutes, with the slides advancing every 15 seconds on their own. It was so much fun. So that video is going to be posted, so I'll encourage you to keep an eye on YouTube. We have a pivotal YouTube channel, and you'll be able to see the architecture behind some of these things that I'm about to show you in live demo. I don't have time to do that tonight, although if you want to stay late, I'll do the Ignite for you. Okay. So what I want to show you is what happens if something goes wrong with one of these application instances. I lose a VM, or I lose one of those containers, or I have a really bad bug in my application, and my application crashes. What's going to happen there? So the way that I'm demoing this is I actually have a part of my application that's going to kill itself. So when I access this link that has broken at the end, this URL, it's going to crash the application. So I hit enter, nothing comes up. Let me come back over here and do a GCF apps. And it hasn't crashed. It hasn't detected that it crashed yet. Now it's detected that it crashed. You see how fast that went? And now, it's taking just a moment. A moment longer. It's a little slow today. I did this demo earlier and I was surprised. Usually, literally the second time I do it, it's back up and running. Oh, now I'm going to be a little OCD. There we go. Now the application instance is back up and running. What's happening there is that the Cloud Foundry Elastic Runtime, the PaaS, has a health management function built into it. So that health management function is constantly comparing the desired state, which was, I need 2 instances of this running, to the actual state of the cloud. It's constantly building up that model based on traffic that's flowing through the system. As soon as it detects that there's a discrepancy, it lets the cloud controller, which is kind of the brains of the operation, know, hey, you're missing an instance, and the cloud controller spins up a new instance. Now, there's some heuristics in there, so that's probably the reason why it's a little bit slower, is that there's some heuristics where it checks to make sure that that app isn't in a flapping state. If it's constantly going up and down, it'll take a little bit longer each time. But that's something that's built into the PaaS. So again, that's an operator benefit. That's an operations benefit, right? So if an app crashes, we'll bring the state of your cloud back into equilibrium, which is really powerful. All right, so any questions on that? Yes, thank you. I totally forgot. It does. So if I come back over here in my logs.
What was the question?
The question was, does it show anywhere what went wrong? And so check this out. Well, boy, the demo gods not happy with me today. Let me try that again. I have to confess I've been having trouble logging over this week. So what I was going to show you was that the stack trace showed up in the logs, and I'm not sure why it didn't. but usually when I do this demo, you can see the stack traces showing up in the logs. Now, we also have additional things. So you've got logging. We also have application performance monitoring. So if you connected this to your APMs tool, we're building one in. It comes from us at Spring Insight, so it comes from the Spring Group. So Pivotal is a company that was formed out of VMware and EMC assets. One of the assets from VMware was Cloud Foundry. Another one was this full Spring Source Suite. So Spring Insight is an application performance monitoring capability. We have it in beta today, but it's being baked into Cloud Foundry. I've worked with a lot of customers that have things like Dynatrace or AppDynamics or OpenView, HP OpenView, and they connect it in themselves. So there's ways to connect. If you're an enterprise and you already have an application performance monitoring solution that you want to tie in, that's something that is pretty easily done. And so it would have ideally showed up in those as well, that you would be able to see it in your monitoring output as well. So yes?
Spring Insight will actually monitor Ruby apps.
So it's going to start with Java, but they do have some agents. I do believe that what they have in beta might even include the Ruby agent. I spoke with David, I forgot his last name. No, not David Lee. It's actually the guy who built Spring Insight. He's more from the Spring Group. David Lee was PMing that for a while. I think they're going to include some of the other agents as well, but it's really strong in the Ruby side, not as strong on the other languages side, but there are some agents for that. Okay, any other questions? All right, so speaking of questions, I tend to get on a steamroll. Please just interrupt me anytime. I don't want you to hold your questions until the end. By the way, I am going to try to get you out of here. It's 7:15. We have a little bit of a delay. My plan was to get you out of here by 8. It'll probably go a little long since we got a late start, so probably closer to 8:15 or 8:30. I have a lot of stuff that I want to show you. But I don't want you to hold your questions. I want you to ask them as we go along. Okay. So let me tell you then about this little project that we did. So this meetup is all about deploying this multi-tier app in Cloud Foundry. So that Hello World app is all fine and good, and it shows some snazzy stuff. But let's start to get a little bit more real here. So this is a project that I started late last year, kind of in the November, December timeframe. It was when I was working with SAP. And SAP built what's called a service broker for Cloud Foundry to SAP HANA, so their database technology. And we wanted to have a really snazzy application where we could demonstrate them deploying an application to Cloud Foundry and tying it to their database service. So we were looking for this application, and we found one. VMware had built a reference application called Spring Trader. It was also called Nano Trader at one point. And it was a reference application that they built to demonstrate their vFabric suite. So a bunch of these other assets that were part of VMware at the time. Things like Gemfire, SQLfire, TC Server, RabbitMQ. So there were a bunch of assets that they wanted to demonstrate all of those assets working together. So they built this Spring Trader application. So that was the application that we decided to use in this exercise. So we already did the pushing an app. I'm going to skip this, which is a little bit of the architecture stuff. I'm also going to skip this. Well, let me just say a few words about this. Just so you know where Cloud Foundry development is coming from, why are we developing this PaaS? What are we thinking about? What's motivating us? What's motivating us is this slide. And the expression, software is eating the world. There was a great article written about 4 years ago by Andreessen. So if you Google Andreessen, software eating the world, it was a Wall Street Journal article that he wrote. Fantastic article. If you haven't read it, I strongly encourage it. Basically talking about the fact that there is not an industry anymore that isn't being disrupted by software. Disrupted by software that's on the web, on mobile devices, and so on. I have to admit that I was a fairly late comer to the whole Uber thing because I live in a smaller town and Uber wasn't in my town until very, very recently. When I started going to San Francisco a lot, I discovered Uber and oh my gosh, it's so different from standing out there and go, taxi, So it's a totally different experience. I never use taxis anymore. I just use Uber. It's completely disrupted, even organized crime in big cities, right? Because taxis were run by organized crime in a lot of these big cities. So it's disrupted everything. It's even disrupted the mafia, right? So every industry out there, and there's some customers up here. So Monsanto is one of our customers, and they are using Cloud Foundry because they are building applications in different ways than they did before. In fact, they're building applications where they didn't have applications before. Those applications, it's not just that there's cool new applications, it's that those applications get delivered to market a couple of times a week. Long gone are the release cycles of 18, 24, 36 months. Remember I said I worked with Documentum? I kid you not. We released versions of our products every 2 to 3 years. I mean, come on. We don't do that anymore. And so the way that every industry has to react now is they have to be able to deliver software products to market faster. That's what motivates us. Every decision that we make and everything that we put into Cloud Foundry is, are we making the delivery of software easier for our customers? The development and delivery of software easier for our customers. That's what motivates us. Let's to get into these disruptive markets. Okay, so let me tell you about the Spring Trader application then. So you see a screenshot here on the left-hand side. It's a rich Ajax-based client. So we've got a web app here, and it's a stock trading application. So it has a web tier that accepts orders, and then it has a fulfillment tier, a back-end tier, that fulfills those orders. So just like if you're using your UBS or your Schwab or your E-Trade or whatever you use to trade stock, you say, I want to buy 100 shares of VMware, and it says, okay, order accepted. It says that right away, that's synchronous. And then some 10 seconds later or 15 seconds later, you do a refresh and it's fulfilled that order. That was a different component. So the application architecture here then is that we have a front end, and the front end is broken out into a couple of tiers. There's the web tier, and then there's a services tier. So this is the UI, and this is a bunch of web services like accept order, allow you to register an account. So there's a whole bunch of RESTful web services here. Back at the back end, we have another, and this is all written in Java, we have another Java application at the back end, which is saying, oh, I see a stock trade order, let me fulfill that. Let me see if you've got enough funds in your account, and if so, we'll fulfill that order. So those are the application pieces, but of course, that application requires a number of services. It requires a database, and it requires a message broker. So what it is, tonight I'll show you is MySQL, for example, and RabbitMQ. And I'll show you how we go about deploying that application. So that's the application itself. Now this, you can find that original application out on GitHub. And this is the Getting Started guide. So this is where we talk about the developer experience. So if you look at this now, I have to say in all honesty that this is kind of duplicated because there's 2 different platforms, so it's really maybe only half of this. But let's read this for a moment. It is, okay, start with Linux. Okay, then you install the TC server, then you install SQL Fire, then you install Erlang because it's needed by Rabbit. You install Rabbit. Then you have to do some configuration, then you have to start Rabbit. Then you have to start SQL Fire, and the list goes on. So you saw the way that I pushed this application. I didn't have to install anything. Okay? So this is the old way of doing things. And we'll see by the end of this session, you'll see how that transformed when I took that application and I deployed it to Cloud Foundry. The instructions are obviously a lot shorter. That's the punchline. Now, so what did I have to do to get the application running over there? Well, I'm really bad at holding my punchlines in check. The punchline is, I didn't have to change any lines of code. The only thing that I really did was configuration changes. But what I'm going to do in this session today is I'm going to step you through what I did to incrementally bring this application from this old way of deploying it into this new way of deploying it. Okay? Excuse me. So I thought, best ways of doing that, excuse me, one of the best ways of doing that would be to walk through the commits in GitHub. So you can find this out on GitHub. It's in a platform engineering organization, which is the group that I work in. Excuse me. I'm going to try this offer. Okay. So the URL for that GitHub organization is embedded in these slides. My handle, by the way, is cdavisafc. I use it on Twitter. I use it on YouTube. I use it on SlideShare. So you'll be able to find these slides on SlideShare under cdavisafc. And so you can find all of that stuff. And the URL for the GitHub repository is in here. And so you can go through the commit history and you can see exactly what we did. So what I want to do is explain that. The first chunk of it happened down here in this commit where I said make deployable to Cloud Foundry. There were some basic things that we needed to do. I had to deal with cross-site scripting. I'll show you why. I had to deal with JNDI. JNDI was an old way of looking at services. What's the new way of looking at services? I'll show you that. And I used a project called Spring Cloud. I'll explain that as well. Now that application that you saw, those 5 boxes, that application consists of 3 pushes, 3 CF pushes, so 3 little apps and those 2 services. And that whole thing, those 5 boxes, make up what I call a big A application. It's a whole application topology. How do we express those application topologies so that things are going to be deployed easier? I'll show you how to do that with apps and manifests. Those are those big apps. I'll talk a little bit about service plans. By then we'll have looked at some services. And I'll talk a little bit about auto reconfiguration, which is when I push something, we do some magic behind the scenes. Magic is not always good, especially in production. It can be a little scary. So you don't want surprises in production, right? So we'll talk a little bit about auto reconfiguration. It goes on. Some of those things that we did initially were a little bit of a hack. So I'll show you what that hack was, and then I'll show you on this slide we got rid of that hack. So I went back to some cross-site scripting stuff. I also will talk a little bit about web services and microarchitectures, or microservices architectures. And that's really what that apps as services is about. Okay, so with that, that's kind of the agenda. Those are all the things that we had to address as we moved this application from the old deployment to the new deployment. Okay, so the first thing to mention is, again, this box, and this box. A, B, and D. They're all individual WAR files. When you deploy something to Cloud Foundry, each one of those WAR files is going to get deployed as a separate application instance. And you want to do that because you might want to scale your web tier at a different rate than you scale your services tier, and at a different rate than you scale your back end. Okay, so you want those things to be componentized. You want to have fine-grained components so that you can manage things at a fine-grained level. When I deployed those things the old way, I'm going to just focus on A and B for a moment. When I originally deployed those the old way, the not Cloud Foundry way, I could have deployed it to something like springtrader.com, and the web tier would have gone into the /web, and the services tier would have gone into /services. But remember when I did that push, and it assigned a URL? Well, each one of the app instances that you push into Cloud Foundry, they get unique URLs. So when I pushed this app, when I went to push this app to Cloud Foundry, the presentation tier ended up at one URL, traderweb.cfapps.io, and the application, the services tier ended up in traderservices.cfapps.io. Now remember I said that this was an Ajax, a rich Ajax-based application? What that means is I now had my web page that was serving up the Ajax at one URL, calling a service at a different URL. Cross-site scripting issues. So I can't do that. That's a security issue. So let me tell you what we did to start. We at Pivotal Labs, we believe in getting something running quickly. And so we started with the simplest solution, which is we collapse those two things into one WAR file. I will admit to you right away, I'm a terrible poker player. I cannot lie. That is a very veiled, maybe not so cleverly veiled way of saying, I didn't know how to do the cross-site scripting stuff. So back in December, I had no idea how to do it. I knew it wasn't super hard, but I was on a tight timeline, and I just didn't have time to figure it out. So I said, okay, great, we'll stick these things in one WAR file. So you can see the commit in the commit history where we glued these things together in one WAR file. And what I wanted to do right now was just explain to you why we did that. We had to do that because we were dealing with cross-site scripting, and I didn't want to solve that problem right away. You'll see later on in the talk how we solved that problem. I'll go over that as well. So that's a hack. We'll get rid of it later on in the evening. Okay, so let me go back to this picture. Now, if you take a look inside of the configuration for this application, so each one of these had a Spring, this is a Spring app, so there were Spring configuration files. Inside of this Spring configuration file, there were lines of configuration that looked up where the data tier was and looked up the connection credentials for the message broker. So it did some JNDI lookups. It was using JNDI to look up the service for the message broker and the service for the data tier. So this is the old way. There was a line in there that looked a little bit like this that said, hey, go look up my relational database, my data source. I'm going to create a data source from something that you're going to find in a JNDI called JDBC/NanoDB. That's where I'm going to get the connection credentials that I'm now going to use to connect to my relational database. I'll skip that. In Cloud Foundry, remember when I showed you the console? I showed you that you had an application area, and in this screenshot there's no apps defined. Then I had services. The services are the instantiated. Those are the services that I have available to bind applications to. So let me go over back to my console, and I'm going to show you how that works. So if I go back to my console, let me instantiate a couple of services. I'll go back into production, and I'll come down here and I'll say add service. Now I need two services. I need a relational database and I need a RabbitMQ. So I'm going to go over here to my relational database. You'll see that these offerings, these service offerings, we offer different plans. So this is all part of the API for exposing services into Cloud Foundry. So we don't just expose services, we allow you to specify various plans, various service levels. So you can see here free and then some of the paid plans. In this case, I'm going to go ahead and just take the free plan for my relational database, and I'm going to name it ST-SQL for Spring Trader SQL. And I'm going to instantiate that into the production space. And that will spin up a new database instance. So there's a database service out there. A new database instance is being spun up. I'm going to do that again. And I'm going to create an instance of Cloud AMQP, which is a RabbitMQ up in the cloud. I'm going to select the free plan. This is where it broke last night. There was something wrong with Cloud AMQP. I checked it earlier. It was working. ST messaging. That's what I'll call my service. I'll put it into production. Then I'll add that, and looks like it's going to work. I'm not angering the demagogues. Oh, now you're making me nervous. Okay, so now you can see that I've instantiated two new services. So now I have a RabbitMQ and I have a relational database. Those are both instantiated in there. So when it came, yes?
So is the database just another schema or table space within one instance?
That's right. What's happening here is on run.pivotal.io, all of those services that you saw in the marketplace are offered by partners. So it's whatever they decide to do, whatever the free plan is that they've decided to do. I am certain that they're not for free giving me my own cluster. So I'm sure that they are taking an existing MySQL service and carving out a little bit of resource, a database, with a username and password. In our commercial offering in PCF, we have a MySQL service. We do exactly the same thing. Today, the MySQL service will carve out a new database out of an existing MySQL cluster already. We are working on some more, basically some higher level plans is on the roadmap moving forward. Great question. Okay, so going back, remember we were talking about JNDI? So going back to JNDI, what I did before was I was looking things up. I was looking up an instance of a database. Well, the place that I'm going to look things up now is here. It's in my Cloud Foundry environment. So how am I going to look up those services by name? That's what I want to show you next in the slides. So one of the things that you'll notice, and the reason that I showed it twofold in here, is that you'll notice that here in the staging, I'm in the staging space, I've called my services Trader Messaging and Trader SQL. And over here in production, I've called my services Trader Messaging and Trader SQL. What's nice about that is that when I'm moving my application through its life cycle from dev to test to staging to production, I don't have to go tweak configuration files. I'm using the same names. Now, these are separate instances. So, for example, in staging, I might have a relational database instance that's a mock that doesn't have real data in it because my real data has PCI, has personal information in it, and I'm not allowed to let staging people or developers see it. So I can call the database the same thing, but it's got different instances at the back end. That's really, really, really powerful. Remember, I keep going back to the operational benefits, right? It's all about not just the developer, but taking things all the way into production. So that's a very explicit choice there. Okay, so the way that you're going to then bind the application, so you're going to bind that services tier to the database, is you use a command called cf bind service. So Trader Front is my front end services tier, and Trader SQL is my relational database. So that's the command that I would run. That establishes the binding between the service and the application. Now you can ask the question of, well, how does the application then pick up those credentials? So when I provisioned the database, I got new credentials. The binding makes the credentials available to the application, but in what form? Well, the form that it makes it available is in environment variables. So how many people have read 12factor.net? Okay, a couple of you. So 12factor.net is a really great website that was written by Heroku people, I think, who have a lot of experience building applications for the cloud. And what they did was they captured those best practices. And some of those best practices are coding best practices, and some of them are process best practices. About this is what we learned are good things to do when you're creating cloud-based applications. One of the things that they talk about is externalizing configuration. You don't want to put configuration in your WAR file because you want to push the same WAR file in development that you do in production. Because as soon as you push different ones, then you introduce an opportunity for error and delays in getting your product out to market. And remember, we want to deploy twice a week, right? Excuse me. So we want to externalize our configurations. And you can externalize it in a number of different ways, but the most general way that exists on every single operating system out there is there's always a notion of environment variables. And so they recommended 12factor.net, and we did the same. We did our analysis and decided to use them as well, is they recommend putting configuration values in environment variables. So you can see here that here's an environment variable, vCap services, that has information about my Trader SQL. So then, does that mean then that in my application I have to make a call out to read that environment variable, parse the JSON, pull out the credentials? And the answer is you can, But if you're writing Spring apps, you don't have to. And that's where Spring Cloud comes in. Remember I said I didn't change my application code? So I didn't write that code. What I did was I changed the configuration. I changed the configuration files for the Spring. So what I do now is it allows me to, instead of in JNDI, doing that JNDI and that lookup, Spring Cloud is a project that allows you to configure things in here to say, hey, I want a data source. Data source means relational database. And I want you to pull those values out of Trader SQL. And it allows you to do, and we'll come back into some of these details in just a moment, it allows you to set some things about that data source, that connection to the database. So it'll automatically do all that parsing for you. All you need to do is put this in your configuration file and include the Spring Cloud jars as a part of your application. So you can see all of the commits that did that. It has a nice little option as well where you can omit the service name. If you omit the service name, here's how it works. It only works if there's a single instance of that type of binding. So if you have an app that's binding to 2 different databases, you can't use this. But if you have an app that's binding to a single database, then you can just write something like this. It will look for the single database that you have bound to the application, and it will just bind to that. So you can even avoid specifying it by name. All right, and then there's a little reminder to me here. I know many of you are developers, so I want to make sure that I show you a little trick. I'm going to go over into STS. Eclipse is not my favorite IDE, but Spring Source Tool Suite is Eclipse-based, so I am drinking the Pivotal Kool-Aid here, and I'm using STS. Now, let's just say here, and I was digging through my code, and don't worry about the navigator, I didn't bother to change the font size on that, one of the many things I hate about Eclipse. But I've got right here my services tier. So this is the RESTful services tier. Let's say I want to run this locally. I've got that Spring Cloud configuration in there, and I want to run with Spring Cloud because I want to test with Spring Cloud. If I do a right-click on this and I say run as, run on server, I'm going to choose Tomcat because that's what I'm going to run up in the cloud, and click finish. It's going to go through and it's going to try to start the application. And that's an interesting, not what I was expecting. Why did that work? Because I thought I got rid of the wrong configuration. Let me check. Ignore the woman behind the counter behind the screen for just a moment. Environment. I thought I deleted these. I must not have applied it. I'll bring them back. So you can see that's the answer. That's the punchline. But let me apply, close. I don't trust Eclipse, so I'm going to remove that. How many times have we redeployed things in Eclipse and it doesn't really redeploy them the right way? Okay, so here's what I thought was going to happen. I thought I cleaned up my demo earlier, but I must not have. Run as, run on server. Let's do that again. That's how you know it's real, right? When it doesn't go as expected. Click finish. Okay, and this time we're going to get a stack trace. Yes, there we go. There was the stack trace. So you can see here that it wasn't able to start up my application. And that's because I had that Spring Cloud configuration in there. And remember I said that Spring Cloud is all about reading the environment variables? It's complaining because the environment variables don't exist. So what I want to do then is I want to set up my environment. I'm going to set up my run configuration with those environment variables. And what I want to show you is where you can get them. So if I go to run configuration and I go to environment, I'm going to add, you have to add 2 environment variables. One which is called vcap application. And the place that you get that is, we'll come back over to the command line here, and we're going to do a, I'm going to change for a moment. I'm going to go over to a different space, target space, Spring Trader deployed in this environment. And I'm going to say GCF files Trader front. Okay? GCF files Trader front. And this is showing me the files that are in my local environment where my application is running. And now the place that I can find those environment variables is down in the logs directory in env.log. And you can see here that there's the vcap application environment variable and the vcap services environment variable. So I can simply cut and paste those values. So I've done a deployment into the cloud, and now I'm just going to steal those values from the cloud-based deployment and do another one for vcap services. Cut and paste that JSON here. Apply. Once again, you're not going to trust Eclipse. I will delete this. Move. And now, when I do a run on server, again to Tomcat, next, finish, the server should start up just fine, like it did the first time when I tried. And we will be able to then execute one of the API endpoints, which I happen to know what they are: API, market, summary. And there we go. There's the JSON that comes out in my RESTful service. Okay, so that's a very pragmatic tip that I wanted to share with you. Okay, so that's Spring Cloud. And with that, I believe that that was the first basic thing. After we made that set of changes, so to review, what we did was we collapsed things into a single WAR file. We replaced the J and DI stuff with the Spring Cloud lookups. And at that point, I had the front and the back end up and running. So we got the application up and running, and we're all set up. But there was more that I wanted to do. And so then the next kind of major commit that you'll find in there was where I created an application manifest. So remember that I was deploying two WAR files. I collapsed the two into one in the front end. So I had two WAR files, and then I had two services. So this is an application manifest. So this is the way that you can specify, instead of having to do a CF push for one of the WAR files and a CF push for another WAR file, I want to be able to do that deployment in one shot. I want to deploy both those WAR files. And you can do that with our application manifest. What the application manifest shows is this top part are global properties. These properties apply to all of the applications that are in the application section. And now you can see that I'm deploying an application. I'm deploying this WAR file, which is the back end, the order fulfillment. I'm giving it the name TraderBack. It's going to use the domain cfapps.io. And so the URL that it'll get is traderback.cfapps.io. And then I'm also deploying that front, this WAR file, again, with those values. That allows me then to do a CF push. It'll read the manifest file, and it'll deploy both those WAR files, do the bindings. So you notice that both of these applications are going to be bound to these services. Okay? So that's something that's in the GitHub repository as well. Now, I wanted to just circle back to, you remember that there were various plans. So you'll notice that in this particular plan, the free plan that I just created for ClearDB, it has 4 connections. So I want to make sure that when I'm writing my applications, that I configure my connection pools so that I'm not exhausting all the connections that are available for my service instance. So in that, remember that the bit of Spring Cloud configuration that we had in here, and I said there were some other properties. Notice that there's one property here called Cloud Pool that has done here is I've said my front end can use 2 of those connections, and my back end can use 2 of those connections. Yes?
Is there a way to split that over your running instances instead of putting it into your, instead of setting up our value here?
So is there, I think what you're asking is there a way that I can specify 4 at the big A level and have them automatically distributed? We don't do that. You might, most of our enterprise customers have some kind of an orchestration layer over the top, and you'll see, by the way, in a moment that the application manifest is something that kind of, it's not as feature rich as it needs to be. By the time we get to the end, we're going to be using scripts. Now, that doesn't answer the question of automatically distributing those. So I think at the moment, no, there's nothing that does that automatically. But boy, that's a really great idea. So, thanks. Okay. All right, so let me talk about auto reconfiguration. So in auto reconfiguration, we do a number of things for you. We do, some of it is in the Java build pack, and some of it can happen, some of that Spring Cloud stuff kind of looks a little bit magic-like, right? So when I first put this all together and I deployed it, it was all up and running. I could run my application. It was connecting to Rabbit, and the orders were flowing, and I was fulfilling orders, and that was all fine and good. And then I went to, I think it was when I was checking this into GitHub, and I did a search or something for Cloud and RabbitMQ or Connection Factory, and I was like, what? I thought I put the Spring Cloud thing because, nobody asked the question. You saw the Spring Cloud for databases. Is it only databases? No. Spring Cloud supports, and I'll show you a slide in just a moment, it supports a bunch of different things. Databases, NoSQL databases, RabbitMQ. It has all of these different things that it does automatically for you, creates beans automatically. So it supports a bunch of different things. And one of the things it supports is a Rabbit Connection Factory. But this is what I found, even when I was checking it into GitHub, everything was running fine. I pushed it into the cloud, and I went to check it into GitHub, and I found that I hadn't used Spring Cloud. So I was like, wait a minute, how the heck is this working? How's it connecting to Rabbit? And part of the confusion for me was that I had heard all of the debates raging on the mailing lists about whether auto reconfiguration is a good thing or a bad thing. And I thought that they had removed it from the Java build pack, but they hadn't. So this line of code, the Java build pack, using Spring Cloud as a helper, had gone in and done that same kind of magic that I talked about earlier where I said the name was optional. It went in and it found in the Spring configuration file, it found this. I see you want Rabbit. It looked in the VCAP services and said, I see there's a Rabbit. And it did that binding for me. And that was a big surprise. Now, it really was inconsequential for me because I'm not deploying this app into production. But it's those kind of surprises that you may not want to have in prod. And so we would recommend being much more deliberate and using Spring Cloud specifically to say, this is really where I want you to look up those values in your environment variables. Okay, so use auto reconfiguration with care, especially in production. All right, so again, at this point, everything was up and running, but remember the hack? Remember the WAR file? The 2 WAR files squished together? Wanted to remove that hack. So I came back and said, all right, back in December, I didn't know how to do the Crosssite scripting thing, so I'm going to learn how to do it. So I did my homework, and I learned about how to do it. And first of all, I had to learn about really what I'm not a security, I don't focus on security, so I really needed to understand what the threat was. And so here's a description of the threat. So in a world where I'm not dealing with Crosssite scripting, I go to a URL like example.com and I get the web page, I get the home page. In that home page, I have some script and I have some AJAX. I'm using an AJAX method. So I'm using the XML HTTP request. This is not actual code, this is just pseudocode. So I'm using the XML HTTP request object to go and access a service that's also being served by example.com. And this script up here is accessing some values from the document that comes back from that XML HTTP request, right? So I do this request and I get back some information. So I get back, for example, the balance of my checking account. That comes back from this request, and this script is now accessing those values, the balance in my checking account. It's okay because the script is being served by a trusted source, the same trusted source that I have here, that's serving up the information about my bank balance. But now, somebody comes along, and some evil site comes along, and it embeds this URL in its web page. So now this is not the example.com web page. This is the evil site web page that looks just like my bank homepage, but it's got some evil script in here. It's going to make this example.com food request. See, I promised there would be food somewhere in here. And now this evil script is accessing the values that are coming back in this document. So coming back from that request are things like my bank balance, and now this evil script wants to access that bank balance. And in order to protect people from these types of things, by default, you can't do that. The request will go through. So for this evil site, the request will go through, but the document will not be delivered back into your browser. Okay? That's the protection that they put in place. If they've managed to hijack your session, so if you have a session open, that request may have gone through with your session token and your values might have been compromised, except that we stopped the document from coming back to the browser. Okay? So how do we get around that? Well, basically what we do to accommodate this is that the service endpoint, so that this endpoint right here, you can explicitly say, hey, endpoint here, example.com, I'm going to allow you to not only return the document values to pages that came from example.com, I'm also going to allow you to return the document results to pages that are called example2.com, but definitely not evilsite.com. Okay? So that's essentially what you're doing. And there's a number of different ways that you can do that. And the way that's implemented and that you can look at in the GitHub repository is I implemented a simple CORS filter. It's really quite simple, especially given that it's a Spring app, was I just created a simple filter, did some Spring security configuration so that that filter is in there. And so basically in the filter it says, did the request come from something that I trust? It did, so I'll go ahead and return the results. Okay? All right. So, where am I going with that? Okay. So, that was the first step. Now that allowed me to separate out these two things. But the next thing that I want to talk to you about is that you'll notice in this picture, going back to this picture over and over, here we have a service, here we have a service. We used to have one app here that bound to this service and this service, and we have an app that bound to this service and this service. But now I've got these things spread apart. So this is an app, but wait a minute, that dotted line sure looks like a binding to a service, right? So this is an app, but I want it to act like a service to the next tier above. Okay, make sense? So I want the application services to look like a service to the layer above. Now let me go back to Spring Cloud. Now remember I said that Spring Cloud doesn't just support databases. Spring Cloud supports all of these things built in. So I can do Spring configuration for AMQP, Mongo, monitoring, MySQL, Oracle, Postgres, Redis, and SMTP. Those are all built into Spring Cloud. But Spring Cloud is also designed so that I can extend it. So what I've done now is in the repository, you can see the code, is that I've extended Spring Cloud to handle a new type of service. And that type of service is a basic HTTP web service. Okay, so I've created a new Spring Cloud extension for a basic HTTP web service. So that's what's going to allow me then to not have to parse that environment variable and to find the URI for that application tier. I'm going to use Spring Cloud to do that. I could have skipped the Spring Cloud extension and written my controller for my web tier to do that parsing itself, but I didn't want to. I wanted to show you how you could extend Spring Cloud. So I did a couple of things. I created this class, basic HTTP web service info. That web service info object, or the service info object, is basically a Java object into which I can now say, please give me the things that came out of VCAP services. Okay, so it just looks inside of VCAP services. Then I also created, oops, sorry about that. I also created another class, which is basically the factory method for that. So it will look for, it will basically do some matching, and it'll create the right type of service. Is it AMQP? Is it RabbitMQ? Or is it my new web service info? There's a very tricky part here, and if you go to this URL down here, that'll take you into the documentation for the Spring Cloud project, and the documentation's there, but it is super dense. It says you have to do this tricky part. And the tricky part is that you have to tell Spring Cloud about this factory method, this factory class. So what you need to do is in a very specific file that's available on your class path, you need to put the name of that class, the full package, the full name of that class. So this is a tricky part. Until you know to do this, you don't know what you don't know. And your files will be in the jar file, and you'll be going, why can't it find my new info creator? And it's because you didn't tell it. You didn't register that info creator. Okay, so now let's put the whole thing together. We now have 3 WAR files and 2 service instances. So you saw me do the CF create service. In fact, you didn't see me do that on the command line. You saw me do it through the user interface. Remember, I went into the user interface and I created the MySQL instance and I created the RabbitMQ instance. I could have done that via the command line as well. So this is what I have so far. Okay? Now what am I going to do? The next thing that I'm going to do is I'm going to push the trader back application. So that was the one that was on the far right-hand side. So the trader back application, I'm going to push that application, and I'm going to bind that application to the 2 services. So I'm going to bind trader back to the message broker and bind trader back to the data tier. Now I'm going to do the same thing with the trader front. So I'm pushing trader front and binding to the 2 services. And now I need to do one other thing. So that is running as an application. At this point, if I do a GCF services, I don't see that as a service. It's just an application. It's not yet a service. So what I need to do is I need to give this kind of a special designation. I want to expose this as a service. Now, there's a number of different ways you can do it, and I promise I'll come back and do a meetup maybe on services and service brokers sometime. We can do that whole thing. Don't have time to go into the details, but one of the ways that we can do that is by creating something called a user-provided service instance. What this says is, this is not a managed service that I can go and do a CF create service on, but I want this to look like a service instance that I can bind something else to. So what I'm doing here is I'm simply doing a CF, PaaS is short for create user-provided service, user-provided service instance. I'm going to give it the name of the service, and then I have to give it what's going to end up showing in the VCAP services environment variable. So I have to give it what it's going to use when I'm going to bind something to it, what it's going to use to connect to that service. Okay? So I run this, and that has the effect of essentially, wait for it, fancy innovation, changing the color. It's an app that's also a service. Okay, so there's nothing to stop your apps from being services as well. So we do that, we create the user-defined service, and now we do the final push of the Trader Web component, and we bind to the service. And now I've deployed my entire application. Now you remember that I showed you the application manifests? Application manifests don't allow me to do that create user-provided service instance. So that's why I had to move from a declarative way over to a scripted way. And if I can show you what that script looks like. And in fact, we're going to try deploying this right now. So here you can see all of those pieces put together. So a little bit bigger. Deploying the front end, making it a user-provided service instance, deploying the web tier, and deploying the back end. So let's just see what happens. I'm going to start this, and then I'm almost at the end of my presentation. We'll see how this goes. So let me move down into my Spring Trader app. And let's see if I've saved that, deploy app. Okay, so GCF services. So again, you'll notice now that it has those, it has the MySQL, oh, I'm in the wrong place. GCF target, space, production, GCF services. So I've got the ST messaging and the ST SQL, which my script here assumes that I've already done that service creation. So it's given, I at the top said, here's the name of my SQL, and here's the name of my ST messaging, my message bus. And now I'm simply going to do a deploy. And, hang on, I know exactly what the issue is. It's got that stupid caret. How did I fix this last night? I went into them. Hopefully this isn't going to stop me from doing it. And then I did a %s Control V, Control M. Oh, I don't remember. Okay. I'm going to pause there and not bore you with that. We can try it at the end, because there's a little bit of something else. So that right there is the state that you'll find the GitHub repository today. So the application topology is now the way it should be. We've gotten rid of the hack. We've demonstrated a bunch of different features of Cloud Foundry, so we're doing pretty good. But there's something that's still missing, something that I haven't managed to implement yet. And let me explain that. So originally, the application was designed to do session state caching as follows. So you can imagine that you've deployed multiple instances of your web tier or your Trader front tier. Okay? So the way that it was originally designed to do session state caching, so that if I hit one instance one time and I've logged in, and I hit a second instance the next time I refresh, that I don't have to log in again. I want those session tokens to be replicated across those. And the way that it was designed to work in the original implementation was that it put a Gemfire node in each one of those instances. And then Gemfire spoke peer-to-peer. So Gemfire is our in-memory database. And it spoke peer-to-peer and it replicated the sessions. So if I hit it here the first time and logged in, my session token was written into Gemfire here. It was replicated peer-to-peer in those other nodes. And so if I hit the other nodes, I was able to log in. This won't work in Cloud Foundry. And here's why. Remember, we're running the application instances on these DEAs. It's not necessarily on the same DEA, but for pictorial purposes, you can see it as a single DEA here. It could be on a bunch of different DEAs. DEAs are multi-tenant. They've got lots of these lightweight Linux containers running application loads. And for security reasons, you want those things firewalled off, right? You don't want two different applications that happen to be deployed on top of the same VM to be able to access each other directly. That would be bad because you might have, you just don't want two different applications to have access to each other. That's one of those security concerns, right? So what we do is, again, we called our implementation of these Linux containers wardens to kind of say it's a very, very secure area. You can't get in or out, right? Well, you can get in. We allow you to get in. You can get out only in very specific ways. You certainly can't get out to each other, and you can't get out from here to the DEA itself. You can't get out to any of the Cloud Foundry components. So you're allowed to get out to the databases, for example, but you're not allowed to get out into the PaaS itself. So that means that I cannot communicate peer-to-peer across these things. So how am I going to do session state caching? Well, what we're looking at doing now is we have implemented, as of the latest version of the Java build pack, we have a very configuration-driven way that you can use Redis for session state caching. It's through a service binding. So basically, if you bind Redis with a specific name, I think it's like session state caching or something like that, we will automatically go into your Spring configuration file and look for those things that are part of your replicated session, and we will use Redis as the point where each one of those nodes can then get the session state. So rather than it being local, now obviously there's some trade-offs. You could say, well, now I have to go out to a service to pick up the session. Redis, of course, is very quick. Yeah, maybe there's some performance trade-offs, but this is one of those changes in the architectural patterns that you might have to look at as you're migrating applications from an old school way of doing things into this new platform. This is not implemented yet. I talked to somebody about it yesterday in the New York Pivotal Labs office, and they right away said, oh, I'll work on that. So I'm hoping that we'll have a pull request in a couple of days, or so maybe it'll be in GitHub soon. Not implemented yet, but it should be coming soon, one way or the other. So the final punchline is this. This was the old Getting Started guide. This is now the new Getting Started guide. You clone your GitHub repository. You have your Cloud Foundry account. You create some service instances like I showed you, and then you run that deploy script that has those stupid *m's in it that I can't do right now. And it does all of those pushes and deploys the application. So that's the punchline, and that is, right around the time that I promised you that I'd be done. So that's it. Okay, any questions? Yes?
Is it specific, but is it possible to create a cloud system or database?
That is a really great question. So our PCF product, our commercial product, includes a number of services. So remember when I went to the marketplace and you saw Cloud AMQP and all that stuff? In our commercial product, the set of services that we offer are Pivotal Hadoop, MySQL, RabbitMQ, and then we have coming, Redis is almost there. It's still in beta, but I think it's moving in to be GA very soon. Cassandra, Elasticsearch, there's a blob store service, and so on. So we have so one of those is PhD. So it's Pivotal Hadoop. So that will allow you from within the PCF environment to say, hey, I want a Hadoop cluster. And it'll spin up an HDFS cluster, and it'll basically spin that up for you. It is so freaking cool because what they've done is they've actually, the people who implemented that service broker, and I promise to come back and talk about service brokers sometime, what they've done is they've implemented a pattern where they, as soon as that service is deployed, so that it shows up in your marketplace, behind the scenes, they automatically spin up a Hadoop cluster, because it takes minutes to spin up a Hadoop cluster. So they spin, it's configurable, but let's in the simple instance say they spin up a Hadoop cluster. And it's just sitting there idle. Somebody asks for a Hadoop cluster, and they get it back in a couple of seconds. And so they're given that Hadoop cluster, and then it starts in the background backfilling that. And that queue can be that you can specify, I want 3 hot and ready, or 2 hot and ready, and all that stuff. So yeah, Pivotal Hadoop is one of the things that we offer in our commercial product. Yep. There's another question over here. thought. No? Yes?
For the services that you're binding to this to the space, can you say that you have control over which applications access which services? Like if I bind a database, is every app all of a sudden going to be able to go and look around that?
So the answer is yes, but. So we're finding that our users, our customers, are using spaces in very interesting ways. So they aren't necessarily using them. I showed you dev, test, prod. We're finding that they have started using spaces to encapsulate applications. So I have a space that's dedicated to my trader application. And then I have another one that's dedicated to my music application. And so that way, and now you have different users that are in those different spaces, so that the service instances that I create for my trader application won't be available to my users that are doing Spring Music. So that's a solution that we didn't anticipate, that just started emerging from the usage of Cloud Foundry out in the marketplace. It's really pretty cool. What else? Yes?
How do you deal with users' SSLs? Is there any special
SSLs. Right. So the question is, what about SSL? So what we do currently, and we have other roadmap items on there, is that we terminate SSL at the load balancer that sits in front of Cloud Foundry. So we don't do any SSL behind that load balancer. So we terminate SSL. But what you're asking is, wait a minute, you're provisioning all these different URLs. How are you dealing with certs? What we do is you configure it with a wildcard cert. So basically, star.cfapps.io, you get a cert for that. And that's the way that it's configured. And that's the way that we deal with it. Good question. Any others? Yes?
Was that commercial capital or data stored in
the MySQL is not HA, but we are currently, if you look at even our public backlog, you can see that we are working on an HA version of MySQL. And Redis, I think it's also dev at the moment. So we're getting the dev ones out there first, and then we'll be working on those. It's definitely something that we want to do. Our strategy around that has been kind of interesting. Initially, if you look way back in the history of Cloud Foundry version 1 from like 3 years ago, we released it with like 5 different services. And then people asked that question. We said, no, they're not, they're dev, they're not. And so we yanked them all, and we didn't actually release any for a while. And we thought, well, we'll let the market come to us. The market's been a little slow coming to us, although we do have companies like SAP who are building brokers. I also just recently heard that Oracle is building a service broker for Cloud Foundry. So you do also have that option. So speaking of Oracle, I have not found an enterprise customer who, number one, doesn't have Oracle, and who is saying, hey, take over my Oracle for me. They're like, no. We have hundreds of man years invested in how we do Oracle, and we're not going to change that, at least not in the near term. I do hear lots of enterprise customers saying, well, we want to move away from Oracle, but they don't want us to do the management of Oracle. So one of the ways that you can bring additional services into Cloud Foundry is you can leave the provisioning and the management external to Cloud Foundry, and then you can use techniques like that user-provided service instance, or you can create a service broker that is kind of managed as part of Cloud Foundry that's brokering something that's externally provisioned. So the near-term answer is no, we don't do HA on the databases that we offer, but we offer ways for you to bring your HA databases into the environment. Yep. Any other questions? Yes?
services there, scope of space?
Service instances get provisioned into spaces.
So you can't
Service.
share spaces.
No, correct. You cannot share service instances across spaces. The service offerings, those are at the organizational level. Exactly. So the question is your roadmap published? So Cloud Foundry, as I mentioned, is an open source project. And so The roadmap for the open source project is absolutely, completely public. In fact, we do everything using Pivotal Tracker, so you can see all of the work that we're doing is all shown in Pivotal Tracker. We, in a very traditional model, traditional open source model, we offer the commercially supported licensed version, which is you don't have to go to trunk and hope that all the pieces are going to work together. We have these stamped versions. But we also have features that are coming out in that product that are not part of the open source. They tend to be more of the add-on services, so not all of the services that we're putting in there are going to be open source. And that, we just, at our conference 2 weeks ago, did go over a roadmap. So we don't have like a place where I can point you to right now and say, here, you can always track the roadmap here. But we talk about that roadmap with customers, and we'll gladly go over that with you. Other questions? All right. Well, thank you so much for sticking in this long. I know that was a long kind of fire hose session, but I really appreciate you sticking around, and I hope it was helpful.